charging system fundamentals part 2. So here we go. We're picking up with the stator number 5. So the stator is 3 groups of windings of wire, like I have here in my hand. 3 groups of windings of wire that are wrapped around a soft laminated iron core. So you'll see, if you can look inside there and get the light to adjust, you can see those little iron bars that they are wrapped around right there. And that iron core helps to intensify the magnetic field. So it says the iron core concentrates the field around the windings. So here's the picture. 3 individual stator windings. One end of this is here. The other end of each of those 3 connects all together. So that's all 3 of those connected together. Now most all of them today are in pairs. So this would be 2 wires, 2 wires, 2 wires, and then all 6 wires are joined at the other end. Here's the laminated core that the windings are wrapped around. Those segmented iron bars will align and intensify the magnetic field on the stator. Remember, this is what's collecting the electricity as the rotor spins inside it. Okay, so stator and a rectifier. And by the way, I should just back up for a moment because it's been a little bit since we did the first part. Here's the rotor, which is the electromagnet. It's spinning. Remember, there's 2 brushes here, and those brushes are bringing in battery power and then ground. And you can see right here, if it'll focus on this guy, you can see that one of the wires down here is going to one of the stator leads, and then the other one up here is going to the other stator lead. And so that's what's spinning inside the stator. So here you've got a stator with the rectifier assembly attached to it. And a lot of times these are soldered on, sometimes they're bolted on. So the rectifier consists of 6 diodes, and actually most modern cars now have 8 diodes, 4 positive and 4 negative, to convert all of those sine waves into just lumps. So they're all positive voltage, no negative voltages. So we're changing or rectifying that AC current into direct current. Okay, let's keep going here. So a Y-type stator has the wire ends from 3 windings. I think it's going to come together. Yeah, there we go. So go slow with me. So the wire ends from the 3 windings are connected to a neutral junction. So they come into the same point. Let me show you what I mean by the neutral junction. So here's my 3 stators. Okay, and they're connected here, here, and here. And they're going to come into this guy here. So, sorry, I want to look at this one here. So these all come together at a neutral junction here, okay, at one spot here. And then they go up to 2 pairs of diodes, 2 pairs of diodes, 2 pairs of diodes. And this is an older one. Usually we've got 4 now. It looks like a letter Y. So the way the 3 stator windings is connected is in sort of a Y shape. This provides really good output current at low speeds. Now we're going to look at this delta in just a moment on the next slide, okay? So a Y-shaped or Y-organized stator gives good output at low speeds. The delta type, here we go, is where, this is basically the same thing, but the text is different. Here's where we align them in the triangle or a delta. Stator wires are connected end to end. So this end to that end, this end to that end, this end to that end. 2 circuit paths are formed during each phase of operation. Okay, so this provides high output, and so this would be in here, and these 3 wires would go in here. This one would go up over here, this one would go up here, this one would go up here. So this gives me a little more high output. This gives me more amperage. The other one does maybe better at low speeds. The other one might be better for a truck. This one might be better for a Mercedes passenger car, which is a higher speed vehicle, but it still has lots of current demand from all kinds of accessories, etc. So next is the alternator fan. And that's our 6th component. We'll just show it up here. And it's mounted on the front of the rotor shaft, but on all modern cars, it's inside now. So this is an old alternator. It draws air through and over the alternator, stator windings, and over the rotor itself. And once again, Here's a modern alternator, and you can see on this one that it's got a serpentine belt drive and all the slots to lighten it up and let air through. But the fan on this one is inside. And on many of these, the fan on this one's actually in the back. You can kind of see it moving in there. If you look right back in here, you can kind of see it moving in there. But anyways, let me turn it like that. You can kind of see the blades moving. But that's sucking air through those slots and cooling that alternator down, okay? It's also cooling the diodes down. So there's a serpentine pulley and belt where the crankshaft turns the alternator belt and turns the alternator. And again, this is an older one because it's on the outside. You need to get some newer pictures, don't I? Some pictures, types of belt. This is a V-type belt. This is what we call a cogged V belt, and there's a serpentine belt. You won't see these too much anymore at all. You only see this style, of course. Let's talk about the voltage regulator. So the voltage regulator is going to control alternator output through the rotor. So if we put more current flow into this rotor, then the alternator makes more amperage. If we decrease how much goes in, we decrease its output. A PCM can serve as a voltage regulator. So a PCM is going to be involved in tailoring how the alternator charges, and it'll shut the alternator regulator down at wide open throttles, again, so that the alternator is not taking power away from the engine. So we give max power to accelerating the engine. And again, it's going to increase or decrease rotor current to meet output demands. So whatever you ask it to give, you turn on all your accessories and the stereo and the subwoofer and everything, it's going to create more output based on demand. So the rotor current is going to be adjusted by the voltage regulator as depending on how much demand there is or how much you ask the alternator to put out. Okay. So alternators are all internally regulated now. So they have inside here, they have the regulator in the back, and we've talked about that already. Just kind of showing some of the components there. So we used to have regulators like this on the fender well. Now they're all solid state inside. And again, this is what a really modern one looks like. On this rectifier bridge back here, you see this heat sink, the aluminum fins. That's to dissipate heat off the voltage regulator. And that's the voltage regulator right there. Okay, and then again, there's the heat sink. So you can kind of see how those fins are to cool that baby down. So charging systems will use what's called a battery thermistor. A thermistor is a temperature-sensitive resistor. So this little guy oftentimes will sit, believe it or not, below the battery, and it will measure the battery temperature. And the alternator or their voltage regulator will respond to that using the PCM to decide how much to charge the battery, because cold battery requires more voltage for charging than a hot battery. And we don't want to give it too much, because the more that we do, the more voltage we give, it's harder on the battery. So if it's not so cold, then we're going to give it less voltage, but we're going to tailor its charging based on its temperature. And you will see these on modern cars. They're mounted on a battery cable or on the tray, or sometimes on an engine control module under the hood. It's a battery thermistor. So the computer is involved to shut the alternator off at wide open throttle for better acceleration. We already talked about that. And it accurately controls charge rate for smaller, lighter batteries. So we can, when we get a smaller battery, we're going to have to be real careful to make sure that battery is doing the job we need. So it's going to be involved on how to charge it. So this is a picture of a computerized charging system. So here's your alternator. Now look at just this for just a moment. Okay, there's the serpentine belt drive there at the front. But hey, we got a delta wound stator in a triangle. We got three pairs of diodes, so 6 diodes. It's a ground symbol. What do you think this is? Well, that's the rotor coil, and there's the brush and the brush on the slip rings. Notice that this is not proportional because those slip rings are way smaller than the coil. All right, there's the PCM or the computer. Over here, ignition switch, Okay, they're showing how power goes on. They're putting an ammeter and a voltmeter in there to kind of do some testing. There's your battery. Sorry, this is your battery here. But anyways, the PCM is going to have in this one, it has the regulator circuit, or controls the regulator circuit. Usually I've seen you'll still have a regulator inside here, but it will control the base of the transistor in that regulator. Let's keep going here. So we've got charge indicators on the dash of all modern cars, and that's going to inform you of operating condition of the alternator. If we have a voltmeter, which is normally what we have, we can look at how much voltage the charging system is putting on the battery. We have a warning light, which is just a battery with a plus and minus. That just, if it comes on, it's just telling you that the alternator is not charging the battery. Old cars had ammeters. You won't see that anymore. You won't see that in any car newer than the 70s. So this is just showing a charging circuit warning light that's going to glow when the alternator output drops to a specified level. So what's going to happen is here's our warning lamp here, and depending on how much voltage we have, if with this resistance wire here, if this is putting out enough voltage, then you will get, you won't light this up, but if the voltage from the alternator drops down, you'll light this guy up here. So a battery is supposed to have 12.6 volts when fully charged, you know that. An alternator must put out a higher voltage, 13.5 to 14.5 is our normal charging system voltage range. Voltmeter shows voltage. Wow, Mr. L, that's really good. Okay, there we go. So that's what our voltmeter is telling us on the dash. All right, so this was a little shorter than I thought. So what we're going to do is we're going to go out to the shop right now, and we'll continue by showing you how to measure charging system voltage with a voltmeter, and how to get an indication, just a really simple indication of whether or not a charging system is charging properly. And then we'll go ahead in the second half of this whole discussion. This is part 2, but this whole second half is going to be looking at charging system diagnosis and so on. All right, so that's it for here. All right, you guys, I've got a 03 Nissan Frontier running here, and I've got my voltmeter here. I'm going to push the leads in, make sure they're ready to go, put it to V for volts. We're going to look at charging system voltage. So I've got a alligator lead for the negative side here, and I'll get my cords untangled. It's always a challenge. So I'll put my alligator lead on the negative side of the battery, and I'll probe for voltage at the battery. I expect to see something around 14 volts. So let's walk over here to the car, and we'll put this guy down. Okay. Put this onto the negative side. And we'll put this on the positive side. We've got 14.34 volts. So that's charging system voltage, so that alternator is definitely charging. And again, if I were to put the red to negative and black to positive, it'll just read negative 14.34 volts. So we can see that this alternator is charging. I serviced this battery. It's a 5 of 18, so it's a 2-year-old battery, 2.5-year-old battery, and it was really low on water. But the alternator is charging at a running voltage of about 14.33, 14.34 volts. So it's able to push push current into that battery because it's got a little more voltage than the battery already has. So I just wanted you to be able to see a quick test of a voltmeter to measure charging system voltage. We'll flip this back off, wrap these around, and that's going to be it for now. There you go. All right, Auto 2, I'm going to be going using this 2003 Toyota Tundra to do a little bit of charging system inspection and some quick charging system tests. So let's take a look at this guy. We have a battery here, and we have an alternator there. And I pressure washed this thing because it was super dirty yesterday. You'll notice that this thing has a brake controller down here. And they've tapped into some wires over here. That one runs back to the back for the brake controller, and it runs up there for the brake controller. And they've cut into the wire here, this one here, that goes from the alternator up to the junction box and then to the battery. I also noticed that there's a ground wire over here that's been disconnected, and we're going to reconnect that. That's supposed to be on the battery right here. They've attached this ground for the brake controller, and they got a little relay for the brake controller here. But in any case, this ground needs to go back to the battery, so I'm going to hook that back up there. But there's the alternator, dirty as it is. And what we're going to do is we're going to go inside the car, and we're going to start it and kind of take a look. But first I'm going to get my cord untangled. And so let's look at our dash warning icon relationship here. And I'll bring the camera around through the window. Sorry for making you dizzy. And so this 03, so here we've got an 03, and I'll get this in here, and there it goes, it lightens up. So you've got over here on the left, you got a temperature gauge, and then you got an oil pressure gauge. You got a tachometer for engine speed, speedometer for vehicle speed. You got a voltmeter there, and you've got a fuel gauge there. This is the SR5, so it comes with these factory gauges. So we're kind of interested in this voltmeter. So I'm going to go ahead and turn the lights on, and hey, check it out. I got a battery light there too that tells me if the battery's not being charged. So in addition to having a warning icon, I have a gauge. So let's start this. And obviously we're idling at about 1500 RPM. You can see the brake light is still on because I got the e-brake on, and the seatbelt light's flashing because I don't have my seatbelt on, but the battery light's on. And the voltmeter is reading up there. If I say between 0 and 18 is the midpoint at 9 volts, then if I go between 9 and 18, I'd say this thing is somewhere up around 15 volts is what that voltmeter seems to be showing. Let's go outside and put a voltmeter on it and just do a real simple voltage test to see if the charging system's working. So I'm going to go ahead and put this guy here. Put down with the alternator. Grab my voltmeter. Let's do this like this for just a second. Here's my voltmeter. Push my leads in. It goes to V for volts. It automatically configures to DC volts. I'm going to go ahead and hook my voltmeter up. The black alligator lead to negative, the red one to positive. If you hook it back up, the meter just reads negative. So we're reading 14.21 volts, or 14.2. So it sure looks like that alternator's charging. The voltmeter says it's charging, but this is just like taking your pulse. It's not a very accurate test, but it does give us a decent indication that the guy is charging. So if we want to do an accurate test, we're going to do a alternator output test. So let me shut the car off. Reach in, shut the car off. I'm going to bring over this guy over here. I'll put the camera back over here. Sorry for making you dizzy. And I'll bring the camera over here where you can see. And I'm going to take these heavy internal 18-volt leads, and I just want to remind you all the instructions you hear for doing an alternator output test. Checking voltage with the voltmeter is like checking your pulse. It's an okay test, but it's not really conclusive necessarily. The alternator output test is going to say, okay, how much amperage and voltage, etc., is that machine or is that alternator going to give us? So we're going to hook red to positive, and there's no spark when you hook this up. Black to negative. Then we'll take our amps connector, and before we hook it up, we have to zero the ammeter. Well, it's already zeroed, and we're reading 12.7 volts. This needs to go around one of the two battery cables, and it's easier for me to get around the negative, so I'm going to, but if there's two leads there, you got to get around both of them. So in this case, on the positive, I've got this lead here, but I also have this lead here, so it'd be hard to get around both of those. So this one goes up inside the fuse box. This one, this positive, goes down to the starter motor. So I went around the negative because I could get around both leads there. So now what I'm going to do is I'm going to start the car, and I have to do two things. I'm going to put the camera up there on so you can see. I have to go over here and hold the throttle up at 2,000 RPM while it's running. Reason to get it 2,000 RPM because when we load the alternator, it sort of bogs the engine down and the test gets inaccurate. So I'm going to go ahead and start the car with my left hand. I'll reach over and I'll hold the throttle up with my right hand. I'll pull this closer. I'm going to go ahead and crank this load meter up until I see this down around 12 volts, and I'll read the amperage. So let me get this guy positioned where you can see that meter. And let me see if I can get him to focus. Focus, dude. Focus. There it goes. So can you see this guy? Yeah, you can read it. Let me start the car. Actually, let me pause for just a moment. I'll be right back. Okay, so here we go. We're going to go ahead and reach over with my left hand and reach over with my right. We'll see what we get here. Maybe I will put the camera here so you can see the screen. Need it there? I don't know if we can. How about we go up here? Okay. Hopefully you can read the screen there. Yeah, looks like you can. Here we go. I'm going to load this guy. We're going to get right about 12 volts. Right about there. About 91 amps. 90 amps at 12 volts. So I had about 90 amps here. Sorry, 90 amps here when I was at 12 volts. That alternator is doing great. 90 amps at 12 volts for a normal automotive alternator like this is normal. We could go to we could go look at Protoman and look under electrical specs, but alternator looks like it's doing great. Okay, there you go.